Oh, good for me. I did that. When you get this whole area out, they're all answers. Anything in that region is an answer, but you might want to try to find one spot in here somewhere where you get the most out of something or the least out of something. Say this was a graph of cost. You'd want to find, and this was the region, these are the acceptable costs in here. You'd like to find the place where the cost is the least. Or maybe you're graphing a bunch of profit. You'd like to find where the profit is the most. That's what today is about. How do you find places in your region where you get the most or the least out of something else? Where something else is optimized, it's to its optimal condition. I'm getting the most or the least out that I could possibly have. Homework due today, 2.6. This is 2.7. You do have homework over this, normal 2-day stuff we'll work on tomorrow. But like I said, you do not need to worry. It will not be on your test. Cool? Not on your test. Oh, there's enough. I don't think I overkilled you, but they take time. So here we go. This is section 2.7. Notes, notes, notes. Weird title. Optimization with linear programming. It's really not about computer programming at all, but found on page 119. Now, first things first, I want you to write down this bottom box, just the bottom box, just the bottom box. And here's your big notes for the day. If you want to find the maximum or the minimum value of something that you're graphing, and I would encourage you to also write down what's on the board here, as far as a cute little example goes. Well, we just talked about in the warm-up what you do. You go graph the inequalities, and you see where their region is, and you fill it in, all that crap. But what that bottom note is telling you is that if you're trying to get the most or the least out of something, it will happen at one of the following points. I would draw it. Yeah, I'm kind of giving you a little visual argument right here of where it might happen. Those spots where your lines cross have a name. Just like in geometry class, they are called your vertex. Or if you want plural, vertices or something like that. You're going to get the most or the least out of whatever you're studying at one of these points where they cross. That is the key thing, okay? Those are big notes for today. Also, they're going to give you things that look kind of different to you that you're not used to. Probably haven't seen this terminology before. You've seen f of x, right? What's f of x mean? It means give me an x, I'll do something to it, right? And I'll spit out an answer. When they say f of x, y, they mean not just give me an x, but also give me a y, do something to it, and spit out an answer. So for example, let's say I had x squared plus y. That's my thing right there. What your job today will be is to find these things. This is most of your work. Find their coordinates. You need to find where these vertices are, because you know that you're going to get the most or the least out at one of those points. What you're going to do is you're going to find these coordinates, you're going to plug them into this equation, and it's going to spit out a number. And you're going to check every single vertex, every single place where these lines cross. That's the boundary of your region. You're going to plug it into your equation. You're going to see which one gives you the most and which one gives you the least. It's a simple concept, but it's going to get dang ugly. So let's look at a few examples and see how this thing goes. Okay, example number 1 today. Write down this system. Boom, this right here. We're going to take our time going through this. You got to see it done. You got to see it done. Example number 1. Nice and slow, nice and slow. We are not going to be testing over this. I agree. It's just too time consuming. This is a very minor topic that will not follow us all year long. Nonetheless, we will be exposed to it and you will have homework over it, so get through it. I'm going to turn decimals into fractions as I go. I see a 0.5, that's a half. And that's about it. Now, you're going to start these problems like you always would. First off, here is the system. See these first 3? Okay, that's your system. You're going to do the same thing you always did with them. We're going to graph them. We're going to see where they intersect, all that nonsense. Down here, this f of xy, this is the thing that we are trying to maximize. So let's dive right in and see what we can do with this thing. Normal business. Let's go graph these. So carefully, I'm going to make a really big one because I want to be nice. 1, 2, 3, 4. Okay, something like this. Nice big coordinate axis here. Let's start graphing them. Okay. Well, first equation. What's this thing look like? X has to be between -2 and 4. And usually you guys probably don't write it like this, but just look at them one at a time. What's the graph of x equals -2 look like? X equals, that's a vertical line, right? So somewhere at -2, here's -2. There's this vertical line right here at x equals -2 until I get to x equals 4, which would be another vertical line. 1, 2, 3, 4. So what the first inequality is saying is that x has to be between these two, so I'm stuck in this region right here. So far, so good? Both of them, yeah. Both of them define the region. It's got 2 of them. X has to be between these 2 things. Here's the 2 things. So far, we're shading in here. So far. Well, what's the second one look like? Here we go. Y-intercept's 2, correct? So I know it's going to cross at 2, and the slope is 1. So every time you go over 1, you're going to go up 1. So over 1, up 1, over 1, up 1. But it's going to look like this. And that's a solid line too, right? They're all solid today, most of them. And it looks something like that right there. There's my second inequality. Third inequality. Its y-intercept is -3, correct? So down here at -3, definitely a point on this graph. It's got a negative slope. It's going to go down 1 every time you run over 2. So we're going to go down 1 every time I run over 2. So something like this. And again, this one is a nice down 1 over 2. Yep, rise -1, go down 1, over run over 2. And that's what inequality number 3 looks like. All right. So let's see here. Where do they all have in common? Well, let's find out. It's got between -2 and 4, right? So we're in between these brown ones, correct? Somewhere in here. We have to be below the green one and above the red one, correct? So I think that would be anything in these 2 cross up here, right? Somewhere. So right here is my region, and that's nothing new that we haven't done already, correct? That's just graphing these stupid things. Now, here's the new stuff. What am I trying to maximize in this problem? In this problem, the function is given by this. F of x, y is equal to, I'm going to say, -2x plus 6y. So somewhere in this black shaded nonsense, I want to find out the spot. Is it here? Is it there? Is it there? Where is it? Where I get the most or the least out of this thing I'm studying. And the main thing today is wherever they cross, this one's going to cross down here somewhere, correct? These 2 are going to cross up there somewhere, correct? So there are 3 places that I have to figure out where they are, because one of them is going to give you the most, and one of them is going to give you the least. Now, here's where the work comes. Okay, I got to figure out where these coordinates are. So let's go nice and slow. First off, this coordinate, correct? Well, actually, is this the one I should draw? It shouldn't quite go that far, should it? Because it has to be past the brown line, right? So actually, more, I should have this because it stops right here. Stops right here. Everything in here. But these two are going to be coordinates. So I messed up the first one. Whoops. All right. Here we go. Let's worry about this point right here, okay? Where is that point? Well, you know something. It's on this brown line, correct? And if you remember, the brown line was where x is -2. So this coordinate right here so far is going to have an x coordinate of -2. But what y coordinate does it have? Well, it not only crosses the brown line, what else does it cross? The green one, correct? Okay, so what's the green one's equation? It's right here, correct? Y is kind of x plus 2. Well, if x is -2, what's -2 plus 2? 0. So y would be 0. So this point should have been drawn exactly at -2, 0. I was a little off. I was a little too low, wasn't I? I should be right there on the axis, but not to scale. All right, moving right along. Got to do them all. So that's tedious. How at this point? Well, again, this x value is at -2, correct? But the y value is far lower because it's on the red line now. Fair? So look at the red line's equation. If x is -2, let's plug it in. What's -1/2 times -2? Well, a negative times a negative is a positive, right? 1/2 times 2 is 1. So I got 1 minus 3, which is -2. So this point is at -2, comma, -2. All right, let's keep it going. We got these two. We got these two to do still. Now, what about this one way up high? It's on this line here where x is 4. Would you agree? So right off the bat, I know that the x coordinate is 4. But where y? Where is it the y coordinate? Well, it not only crosses the brown line, it also crosses the green line up there, right? That's where the green hits the brown. So if you look at the green equation, and you know x is 4, 4 plus 2 is 6. So y must be 6 up here. And down here, this last point, again, it's on the brown line, so x is 4. But it's also hitting the red line this time. So if you go to the red line equation and plug in 4, -1/2 times 4 is -2. -2 minus 3 is -5. That is by far all it's going to take your time. Logically figuring out where these things cross and where they intersect. Now, here's the main theme of the day, ready? Whatever I'm studying, this thing, is going to be the most or the least at one of these vertices. So we're going to plug them in one by one. The first point, let's just go in order we did, was -2, 0, correct? So when I plug in -2 for x and 0 for y, what do I get out? Well, x is... which one? 2x plus 6y? Because that's the thing I'm studying. That's the thing I want to find at any x or y, what it is. So if I pick the point right here, it's got an xy coordinate, correct? I can plug into this thing and I can figure out exactly what it spits out. I can pick a point here. I can pick a point here. Any in this black works, correct? But our theorem today says if this thing, whatever I'm studying, all I care about is the corners. All I care about are the vertexes. And it's going to get the most or least out of one of them. When you plug -2 in for x and 0 for y and do the math, you get out 4. So this thing I care about spits out 4 at that point. And we keep doing all these points as we go around. What is it at this point when I plug in -2 and -2? Well, I'm replacing x with -2 and y with -2. So -2 times x, which is -2, plus 6 times y, which is also -2. That's 4. That's -12. 4 minus 12 is -8. So at this point, I'm getting out -8. And we just keep going around doing this up for all the points. Let's go down to the bottom right, 4, -5. When you plug in 4 for x and -5 for y, we get out -2 times 4 plus 6 times -5, which turns out to be -38 when you do it all. And lastly, the top point at 4, 6, when you plug in 4 for x and 6 for y, you get -8 plus 36, which is 28. Okay, what's the point of all this? Well, which one is the max? Which one's the highest number you got out? 28. This is a maximum. This is the maximum value of this thing anywhere in the black. Anywhere in the black, if the highest one you're ever going to get is at the point 4, 6. Which one's the smallest number? -38. So this is a minimum. Anywhere in the black, that point 4, -5 is going to give you the least value out. Pain in the butt, but this is how you do it. Okay. Well, I think finding those points initially kind of sucks. That takes some time. Let's try another one. All right. For everybody at home, this is what we did. Gonna look back on it. Example 2, write her down. Woo. Pain in the butt. Pain in the butt. More practice. More practice. All right. Here we go. Example number 2 right out of your book says that y is between 1 and 3. Second equation says that y is less than -x. Equation 3 is y is greater than or equal to, and I'm going to change that 0.5 to a half because I like fractions, plus 3. And this time, the function that we are cared about maximizing or minimizing is given by at -x plus y. All right, here we go. So let's start off by just drawing the region of this stupid thing. Here we go. The first inequality says y has to be between 1 and 3. Now, what's a y equals graph look like? An x equals is this, right? So a y equals is that. So where's y1? Right here, correct? So this line, and I'll start using some color codes to indicate what's what. This one is going to be more than 1, but less than 3. So this first one's saying I'm between these two lines. Y is between 1 and 3. Only in here. This is the only region I have in my life right now, right in here. Second one. Y is less than -x. Well, what's a graph of -x look like? There's no intercept, correct? So it starts at 0. And the slope is -1, so it's going to go down 1 every time I go over 1. So over 1, down 1, and that's probably good enough. I got 2 points. Let's go ahead and connect them. Solid line again, right? Solid, solid, solid all day today. So there's inequality number 2. And inequality number 1 kind of had 2 parts to it. Third inequality. Y-intercept is 3. So I know it'll start up here at 3 right there. And the slope is 1/2. So I'm going to rise 1 every time I run over 2. Up 1 over 2. So up 1 over 2. There's another point. And again, this one will be a nice solid line. Something like this right here. All right. Now, where do I shade? Well, it's got to be between the brown ones, correct? It's got to be below the purple one and above the green one. So So where am I below the purple and above the green? I would think it's right in here. Would you agree? Here I'm above the green, right? But below the purple. So this is my region right here. And where do they intersect? Well, number one, this goes on forever over here, doesn't it? But this is the key thing I need to know is where are all the vertices? Here's one where these two cross. Here's one where these two cross. And then there's one where those two cross. So I have 1, 2, 3 vertices to figure out where the heck they are. Let's get to work. Where are these vertices? Well, I don't know. Let's start with this one. I know something about this. The y value here is what? What's the y value on this brown line down here? 1. Okay, so I know that this is something comma 1. Y is 1. Now, how am I going to figure out the x? Well, it's not just on the brown line. It's also crossing the green line, right? So if I go look at my green line equation, and it says y is 1/2 x plus 3, well, I'm going to drop the inequality for a second, because this is actually where they're equal. You know, when they cross, that's where they're equal. If y is 1, well, I could figure out what x is then. If you subtract 3 and multiply by 2, looks like x is -4. So this point is at -4, comma 1. Look at all the work I had to do just to figure out that thing's coordinate. Okay, there's 1 point. Let's keep working. How about this dude right here? That's the hard one, because I got nothing to go off of. I don't know what x is there. I don't know what y is, but I do know that this is where the purple and the green intersect. Would you agree? So the purple and the green, where they're equal to each other, if you go write them out as a system, look at this thing. Could you solve this now that you have substitution elimination stuff? Yes, you could. We're going to have to do that. Let's subtract these two equations from each other. Y minus y is nothing, correct? Do an elimination. -x minus 1/2 x would be -1 1/2. I'll go to decimals for you. X. And on this side, there's no number here, right? 0 minus 3 is -3. And if you move the 3 over and divide by the -1.5, you get x is -2. So this coordinate, the x is -2. And like any system, once you know it, you can plug it back in, right? If you go back to this equation right here, if x is -2, -2 would be 2. So y is 2. So I found that point. Ugh. Here we go again. Last one. This one up here. I know something about this one because it's on the top brown line. The top brown line had y was 3. So I know this coordinate right here is going to be something comma 3. How am I going to figure out the x? Well, this point is on the brown and the purple, right? So if you go to your purple equation, y is -x at this point. And if y is 3, then that must mean x is -3. So this point is at -3 comma 3. Ugh. All right. Groundwork's done. Got our region, got our vertices, everything is good. Now all I got to do is figure out which one of them makes this thing I care about a max or a min. So f of xy, by definition, what they gave us is it's -x plus y. We're going to plug in every point one at a time. How about -4, 1 to start? If you plug in -4 for x and 1 for y, you're going to get negative times x, which is -4, plus y. -4 is 4. 4 plus 1 is 5. So this thing I'm studying, which I care about at that particular quarter, gives me out a value of 5. How about here at -2, 2? Well, let's plug in -2 for x and 2 for y. Here's my equation. So it says -x, x is -2, plus y, which is 2. And if you do the math on that, it turns out to be 4. Lastly, this one I haven't checked here, negative 3, 3. Let's see what happens at negative 3 and 3. That gives me out a value of 6. So your theorem today, the one thing is that the maxes and mins have to occur at one of these. So which one's the maximum? 6 is. So right here, this is the max value of this thing I care about on that region. And the lowest one's 4, right? So that's my minimum. That's the minimum value of this thing in that region. Here's the maximum value of this thing in that region. Sucks, doesn't it? I don't enjoy talking about it anymore than you hear about it. It's kind of a stupid lesson. I would agree. Yeah. Yeah, it's going to be a lot of tedious nonsense. Let's try one more, and then we'll call it a day.
You said it last time.
I lied. We're going to do a word problem. Yeah, I'm excited. This is going to be brutal. But if you suffer today, I won't put it on the test. That's the trade-off. Suffer, do the homework, try. I won't make you do it on a test. That will save your life. Ready? Set. Go. Avery has a 30-foot square plot in the school greenhouse and wants to plant lettuce and cucumbers. Let's use C and L for that. Cucumbers and lettuce, fair? So we're not going to use X's and Y's, which can make it even more confusing, but that's okay. Each cucumber requires 2.25 square feet of space. So 2.25 times C would be how much space is needed for the cucumbers. Each one is 2.25 times how many cucumbers you got. That's the space for the cucumbers. If you read on, each lettuce plant requires 1.5 square feet. So similar logic, 1.5 times L will give me the area done by the lettuce. The total area of these two together has to be less than or equal to, well, how much area is there total in my garden? 30, right? So you got 30 square feet. So she can make as many as she wants, but you can't exceed 30 because that's as big as your garden could possibly get. So here's one equation. Equation 1. Let's write that down. Okay. Other stuff they're talking about. What are they talking about besides square feet? They're all talking about gallons of water, right? Let's start with the gallons of water. So each cucumber uses 25 gallons of water. So 25C will be how much water is used for the cucumbers. Also, each lettuce plant requires 17 gallons of water. So 17 times how much lettuce I got, that's how much water is used by those. Together, that will be the total amount of water that is used. Do they say how much water should be used? No, in the end, they say determine how many of each plant should be plotted to minimize her water. This is the equation I'm going to try to minimize later on. So usually I'd say f of xy, but I'm going to say f of c and L. Give me a c and an L, I'll spit out. That's what we're going to come back to way at the end of the problem. In fact, I'm going to put it up here just so we don't worry about it for right now. 25c plus 17L. Okay. What else did I say about this problem? There's other numbers in here we haven't talked about yet. She wants to grow at least 4 of each type of plant. That means the number of cucumbers must be at least 4. And the amount of lettuce must be at least 4. She also says that she wants to grow at least 4 of each type of plant and at least 16 plants in total. So the total number of plants, the cucumbers plus the lettuce, must be at least equal to 16. Whew. All right, we got it. Here comes the pain. Well, let's try to graph these things. Which one do you, since it's C's and L's doesn't really matter, which one do you want up here? C or L? Pick one. C. All right, C's up here. L's down there. And normally, if we're solving graphing equations, we have y equals, right? Well, in this case, since you put c up here, we want to get everything to be c equals. Well, that sucks. That's not c equals, is it? Well, we got to work on it. So let's reword equation 1 and try to get c by itself. To get c by itself, the first thing you do is subtract this over, correct? So 2.25c is less than or equal to negative 1.5L plus 30. And now to get the c by itself, we're going to have to divide by 2.25, which means everybody gets divided by 2.25. We're trying to get c by itself so we can graph it. We usually got y equals something, right? Well, since c is up here, I'm going to need c is something. So we're just working on getting c by itself. And it's almost there. Let's divide everything by 2.25. 1.5 divided by 2.25 is gross. I'll tell you what it is. It's negative 2/3. 30 divided by 2.25 is, I'm getting lazy. We'll just put as a decimal, 13.3-ish. All right. So there's a better version of equation 1 that I can actually go graph. Let's go graph it now. Here we go. The intercept is 13.3, correct? So wherever we got up here, this is 13.3 as a point. We'll say it's about 13.3. The slope is negative 2/3. So every time I go down 2, I'm going to go over 3. I don't know where that is. We'll just call it right here. Good enough for an estimate. So this is inequality 1, roughly. Something like that. Going down, cross to the 13.3, we're okay. Two is ready to go. It says c has to be greater than or equal to 4. Now, here's the c's, right? C's is up and down. So it has to be more than 4. Well, where's 4? I don't know. Let's say it's about here. So it has to be above this purple one. Equation 3, the lettuce has to be more than 4. Here's the lettuce. Let's say that this is 4. So this would be what the lettuce being 4 would look like. And lastly, equation 4. Oh no, c is not by itself. But we can fix that real easy. All we got to do is move the L over. So c is greater than or equal to negative L plus 16. And that would start up here at 16. So let's say this is 16 right here. And it's going to have a slope of negative 1. So it's going to be slowly going down. I don't know. Where are they going to cross? I don't even know. Let's just say it's over like this or something like that. Good enough. All right, let's see if we can get some kind of outline from all this crap. This is mess. Here we go. First off, equation 1, the red one. You want to be lower than the red one. So that would be down here so far. So good? All right. Equation 2, we need to be to the right, or c is greater than 4. So it has to be above the purple one. So below the red, above the purple, so far we have this little triangle here. Next, we have to be, the green one has to be more than 4. So we're kind of in this region here. And lastly, we have to be, what, greater than the brown line? So I'm thinking it's going to be something like this. I'm thinking this is our region right here. Ish. Now, let's not do all the points. I'm tired of this. Let's just do a couple of them. How about this point right here? Well, can you tell me anything about that coordinate? It's on the purple line, correct? And on the purple line, c is 4, right? So c, what I got out, and what I get out is the y's, right, is 4, check. It also seems to hit this brown line, right? On the brown line, if c is 4, and you move things around real quick, looks like L would be 12. So right here is a point 12, 4. And you would do this for all the points in your region. I won't go through it because I'm getting tired of this crap. But what do you got to do with all the vertices once you get done? Plug them into the thing you actually care about, right? So just as an example, C, what's the point right there? C is what you get out. It's 4, right? And L is what you put in, which is 12. So plugging that in, you'd have 25 times 4 plus 17 times 12. You'd get out some number, correct? And then you're done. You go next point, right? Do it again. Go next point. Do it again. And whichever one's the most, you say it's a max, correct? And whichever one's the least, you say it's a min. And that is a pain in the butt. But unfortunately, that's the next topic, which is why I'm not going to force you guys to do it on your test. Cool? But do suffer through a day of it. So there's your homework. 2.7 is the new one. It's due in a couple days.
Wait, can you write an equation on the board really quick?
What kind of equation?
8 divided by, no, like divided.
It's the same thing.
No, I want it to be, no.
Like an elementary school kid?
Yes. 2, then parentheses, 2 plus 2, parentheses.
It's a PEMDAS question.
Solve it.
Uh,
I texted James, and I said, what is it? And he said it was 1. And then Maggie said it was 16.
16.
How?
Well, PEMDAS, right? 8 divided by 2. This is just 4, right? Okay. Now, with PEMDAS, you know, addition, subtraction, they're a tie. I know they say PEMDAS, so you think addition comes before subtraction, but really it doesn't.
Bro, we're not doing it.
I know. But these two are really a group. Addition and subtraction go together. Multiplication and division go together. So when you break the tie, you just read left to right. So the first thing I see is 8 divided by 2, which is 4. And then I did.
No, you do the 2 times 4 in parentheses.
No,
Yes.
you're multiplying. That's just, you're distributing that out. Parentheses is just 2 plus 2, which is 4. And then you just go left to right. So 8 divided by 2 is 4. 4 times 4 is 16. So 16. Just like we do x. It's just like if you do this, you don't do 2 plus 4 first, do you? First, you just go left to right, correct? 8 minus 2 is 6. 6 plus 4 is 10. You just go left to right if it's addition and subtraction. Well, if it's multiply and divide, you just go left to right also. So 16. Word. I hate this lesson. Really don't like it. Good luck. I hope the problems do a lot of the work for you.